This video will provide a walkthrough of a Python SQLite Flask application which is based on a PHP MySQL example created by Richard Kelly. The audience targeted is primarily Queensland teachers who teach digital solutions, teachers who are interested in viewing a Python version of the PHP example, and that relates to IA2 and IA3 tasks, teachers who are interested in seeing a MySQL conversion to SQLite. Those who have significant experience with Python and Flask may or may not find this helpful. Assumptions: viewers have some experience programming using an IDE. I will be using Visual Studio Code. It is helpful that viewers have a basic understanding of Python, SQL, Flask, HTML, and CSS. Areas touched upon: Python, Flask, and SQLite will be discussed, but only lightly. The aim is to provide an overview of the application rather than provide something more detailed. PHP and MySQL will only be referred to as needed. As mentioned, Visual Studio Code will be used for demonstration, but how to use this IDE is not covered. And lastly, links to the code used for the Python SQLite Flask solution will be provided. Overview of what will be covered in this video. First, we will look at the environment used to create the Python SQLite version. Next, we will look at the project folder and see what it contains. There are three approaches for creating the database. This will look at using and converting the original MySQL, and then using Python as another approach. Next, we will review the modifications made to create the Python application, and then lastly provide some closing points. The environment can be used for OS X or for Windows. It's Python 3, 2 packages are required, Flask and requests. DB browser for SQLite is used to help check the database, and the IDE is Visual Studio Code. The project folder contents: line 2, the main application, app.py. Line 3, the database, BOM.db. This is the SQLite database used in the application. On line 4, the affinity check SQL is a SQLite script used to check the data conversion of the MySQL data types. There are 3 database schema files. Schema.py is a Python code used to create and populate the database. Schema MySQL.sql is the original MySQL script. And then schema SQLite.sql contains the SQL converted from the MySQL to SQLite. And then SQLite.txt is just the original MySQL script. On line 9, the static folder contains the modified index and CSS style sheet. The static folder is used to hold assets that do not change but are needed in the Flask application. Starting at line 12, the templates folder contains the templates used to dynamically generate the web pages. The templates are HTML files that contain Jinja templating code. Creating the database. The first step is to convert the MySQL query into an SQLite query. It means manually editing the original query. The original MySQL script uses the following data types: varchar, date, decimal, and int. For SQLite, these MySQL data types must be converted. Varchar becomes text, date becomes text, decimal values become real or numeric, int becomes integer. It is important to know how dates are stored in SQLite. SQLite does not have a date data type, so date values are stored as strings. SQLite provides a specific structure for storing dates, as shown in this example. With this format, dates can be easily stored and used in conditional statements, such as checking whether a date exists between 2 dates. In contrast to MySQL, SQLite text data type doesn't provide setting string lengths. In order to limit the length of a string, the check constraint can be used, as shown in this SQL example. The check constraint can be applied in the table definition. Alternatively, code can be used to validate the length of a string. For this solution, some length constraints have been applied as an example. Let's look at our example. Let's look at the SQLite script. At the top, we have begin transaction. This stops SQLite from auto-committing each SQL statement. We drop the table. We create the observations table. Here's an example of the check constraint and how it can be applied at a column level. We drop the table of stations. We create the table for stations. And then we insert the data for both tables. At the end, we have a commit. This finalizes the transaction and allows SQLite to go back to auto commit mode. So let's delete the current database, and let's start SQLite. Let's open the database, BOM data.db. Now this will open or create a database file if it doesn't already exist. Now we read the script, and this will execute the script and create the database and populate it with data. To check, let's create a query. This is going to set the layout for us, and now we can do the query from the stations, and that shows that the table has been created and populated with data. Let's go to DB browser to see the database itself. So let's open the database and check the structure. Okay, so this has the data types that SQLite supports. Let's browse the table just briefly to see what's the information. Okay, so everything appears as it should. Let's go back to the application. Let's close the database. And let's quit SQLite, and we'll start the application. Here we have the daily. We can just pick a station, and yes, it populates the data. Everything is there as expected. Okay, so we can close this. We can go back to our application, and we can stop. Control C twice to stop the application. To summarize begin transaction, SQLite by default is set to auto commit. When an SQL statement is executed, it is automatically committed. Begin transaction stops the auto commit mode. This means multiple SQL statements can be executed without being committed. The commit finishes the transaction and allows SQLite to return back to auto commit mode. And using begin transaction and commit allows the ability to roll back all changes made. It is useful when all SQL statements must be executed successfully. Creating the database. And for review, here are some of the SQLite dot commands that were used. So here we have .help that gives all the commands. Open, as mentioned before. .databases shows what has been opened. .read, as mentioned before, executes the script. .open, without any argument, closes any open databases. And .exit or .quit closes SQLite. Some other commands, headers on and mode column allow us to create queries that are formatted in a reader-friendly format. Another approach to creating a database is to use the MySQL script without any changes. It will mean executing the MySQL script using SQLite. This will use SQLite's affinity to convert the data types from MySQL. Let's look at an example. Let's look at the MySQL script. So here's a MySQL script. It simply creates a table, populates it, creates the next table, and populates it. So let's start SQLite. And before we start, let's delete the existing database. Okay. So we'll do .open and BOM data.db. So we'll recreate the database. We will read the schema. SQL. Okay, so now we've executed the script. To check, let's create a query and select, stations, and there we have the database, and data has been loaded in. So everything appears to be working fine. Let's go to DB browser to check the database. So I'll open up the database, BOM data, and let's check the structure. Notice that the MySQL definition has been saved as part of the database. These are not the normal data types for SQLite. If we go to execute query, now I've already loaded up the query. So this query checks the data type for each column. And so this allows us to check what was the affinity conversion. So we'll run the query and we can see that, for example, min temp is real, max temp is real, date is text. Let's go back to the database structure. Now notice here date, we have it as date, but that's the original from the MySQL, but SQLite automatically converts that to text. Notice here we have decimal, but as we saw in the query, it's been converted to real. So that shows how the affinity is used in SQLite. So let's run the application and check out how and whether the application runs properly. So let's quit out of SQLite, and we'll just clear the screen, and we will run the Flask application. Go to the browser. Okay, so far so good. If we click on daily weather, which uses the database, so we'll select say Brisbane Airport, and everything appears as expected. So it shows that we can use the MySQL queries in SQLite and it still works. So let's close this, go back to our application, and press Control-C twice to close the application, and we'll just simply clear. Although SQLite stores the MySQL table definitions, SQLite actually converts the data type based on its affinity. The table on the left shows the MySQL data types for the table, and the table on the right shows the actual data type applied by SQLite. The third approach for creating the database is to use Python script. The Python script contains two functions. CreateDB, it creates a database and table. Upload data function inserts data into the database. There are two ways to execute the Python script: at the command line or import it as a package. Let's look at our example. Let's view the code for schema.py. So we import SQLite 3, we set the database file name, and we have two functions: CreateDB, and it requires the file name of the database to be passed as an argument, and it returns true if the database is successfully created, false if not. We set the flag to true, and then we create the query itself, which basically creates the tables. And then we execute the script, commit, close. If there is an error, it will be trapped here and set the flag to false. And if it's successful, it will return true or false if something went wrong. Upload data is the other function. It also requires the database file name passed as an argument. It returns true if the data is successfully loaded, false if not. The same setup. We set the flag to true. We make a connection to the database. We create the query. Now this query is different because the first thing we do is delete everything first, and this is to prevent duplication of data in the database. And the same goes for the other table. We delete everything first before reinserting the original data. We execute the query, we commit, close. If there is an error, it gets trapped here, and the flag results are returned. The last section is executed only if the Python file is executed on the command line. When that happens, we execute both functions. We trap the results of the execution. If successful, we get that the database was created. If it wasn't successful, then we'll get this second message. And the same is true for uploading the data. So let's execute this command from this program from the command line. So we'll have Python and then schema.py, and notice the messages were printed out. The database, and just to make sure, let's just remove BOM data.db, and so now we've recreated the database. Let's check the database in DB browser. Go to the database structure, and we need to open the database first. Check the database structures, and we have the data types of SQLite, and the same for station. We can browse the tables. All the data is there as expected. So everything is fine from that point of view. So let's go back to the application, and let's run the application to check if the data works in the application. Okay, so everything works as expected, and it works. So we'll close this, go back to our application, press Control-C to stop the server, and we'll clear the screen. The other way we can execute the Python script is by using it inside another Python program. To simulate that, we'll start Python on the command line, and that gives us interactive Python. And we will import the schema. The schema is now imported, and we can use both functions separately. So we want to, actually before I do that, I'm going to exit this, and I'm going to delete the database first. And then I'll start Python again, and then import schema. And now we can start creating the database. So let's create db and BOM data.db. So that's the file name. So it returns true, means that the database is created. So if we go to DB browser and we open the database, okay, here we're browsing, and so there is no data, but the tables exist. So we go to the structure, and this does apply the SQLite data types. So we'll just check both tables. So that's what we were expecting. So we'll go back to our interactive Python, and now we'll execute the other function. And that was upload data, and we pass in the file name again. Execute it, it returns true. Now if we go back to SQLite and we browse, and we have the data in the database now. So that worked as expected. So we'll just go ahead and close this, go back to our application, and we'll exit Python, and we'll clear the screen. And that shows that we can use Python as a normal script from the command line, or we can actually include it as part of another Python application. Now that the database has been created, the application can be created. The following files from the original PHP program will be converted. Note that daily.php and functions.php will be converted together. Converting index.htm. The original PHP application index.htm is the home page. It doesn't contain any PHP coding. For the Flask application, it has been converted into a template with the same file name. Daily.php and functions.php are converted into the daily function in the app.py program and the template daily.htm. The daily function handles processing the data, and the template handles presenting the data. As you can see, the functions.php has been made part of the daily.htm template. Latest PHP is converted to the latest function in app.py, and template latest HTM. The function handles processing the data, and the template handles presenting the data. To kind of get an overview of the changes made, in the PHP application, specific files respond to URL requests. For the Python application, the URL requests are handled by Flask, which executes the function associated with the URL. In turn, each function has its own template, which is used to dynamically generate the requested web page. Let's look at our example. Let's look at our main application file. Here we have Flask. We initiate or instantiate the Flask object. We set up the database file name. Our first route. So here is the home link, and it's associated with the index function, and all it performs is returning the template. So if we look at the index template, the only code that's inside the template, and this is Jinja templating code, is one that automatically generates the URLs for the style sheet and the URLs that are associated with the function daily and the URL associated with the function latest. So if we start the application and go to our browser, now if we right click and look at the page source, notice that our Jinja templating, the URL fork function, converted that into a proper URL link to the style sheet, and also we have the associated links for the functions in the Flask application, and they work as expected. So we'll go back to the application and back to app.py. Now we'll look at the next route for daily. So here's the URL that's linked to this function. It can handle both get and post requests. At the top, we set default values for the variables that are used in this function. We make a connection to the database. We set up a row factory, and this provides us a dictionary format for the data that's returned from our queries. From there, with our default values, if we don't get a post request, it simply closes the database and then renders the template. The template requires data in order to run properly. And there's a difference between the Python variables and the template variables. So we have to transfer the data from the Python code over to the template code. And so this is what is occurring here. So station is the blue variable, is the Python code. That is being passed to the station variable that's part of the template code. So we have stations, from date, to date, S data, B fields, and some data. So we have to pass all the data to the template. In going through the template, so look at daily, and we just page through. So we can look for the Jinja templating code, and this is identified by the curly brace and % symbol that identifies control structures. Double curly braces identify displaying information stored in a variable or the results of a function. So here we have, we're looping through all the stations that make part of the options that are available in the form. And going through the code, we have the next set of Jinja code here. Now this is a much larger block, and this generates the display of the data. So here, this is making sure that we don't have the default station. We go through each row of data that has been passed to the template. The template for each row, so now because we've passed through the data as dictionaries, we have a list of dictionaries being processed. So row.name what that means is in our for each row, it's actually a dictionary. And in the dictionary, we're pulling out the key name, the key latitude, longitude, and elevation, and the value that's linked to that. From there, we go through the fields, so we actually get the field names, and that helps populate the table. And then we go through the data, and again we go through the sum data, and again, because it's in the dictionary format, row and the key is min temps, so that retrieves the value for that column, and max temps and rainfall. So that's the template for daily. So going back to our application, if we receive a post request for daily, so it means the user has made a selection on the form. So we still populate the default data. We create the connection to the database. We set up a dictionary format for the data. We check the request method that was used. So we make sure that we have a post. In other words, we want to make sure that the user has actually sent us data. So now we grab the information from the form that was in the template, and each of the controls have these names. So if we go back to daily and we go to the form, so at the top, so we've got, here's the name station, so that's that control. We have, so here we got the label, so input date name, so there's the from date and to date, so those are the three controls. So we go back to our application, so here we get the information from those three controls. We make sure that we do not have the default station. We make sure our connection is still available, and we then perform a try, making sure that our SQLs execute correctly. So here we get a list of the stations, and we store that in S data or station data. Next, we execute for observations between the dates that were provided in the form. B fields is used to store the field names. This is a comprehension, and it goes through a special property called descriptions, and that contains a list of the fields. That has to be extracted, and this is what the comprehension is used for. From there, we take the data from this query and add it to B data. So now we have S data for the stations, B data, okay, for the observations. Now, we have to get a summary of statistics for the BOM data. And note, rainfall total is calculated as an integer, and the template converts it back to a decimal. This is important. I found that there were problems, and so you have to watch out for decimal numbers and how to handle them. So making sure that we don't have any null data for our from and to date, we then set up a query for that information. We make sure that rainfall is calculated, and we multiply it by 10 first, and we'll correct that in the template. So once that's completed, all that information is, and then we also get some additional information. So we need to get all the stations, and then we send all of that information to our template. Going back to our template, so just to check this particular, the rainfall. So let's go back and take a look at how that's handled. So here is the rainfall. So now we divide by 10. So when we were processing the data to get the aggregate, we multiplied by 10. But when we are displaying the data, we divide by 10 so the correct value is displayed. So now we can go to our next route and function. The last function, we have the URL that's associated with this function, latest. It can also handle get and post requests. It follows the same format as the previous function. We first set up default values. So those are all stored in variables that we use in the form and needed in the template. So we make sure all that is set to default. If we get a get, that's all that happens. So we simply return to the user the template, and we pass the data, the default data, to the template. So if we looked at that, so we go to latest, and going through here again, it's pretty much similar to the previous. We simply go through the locations. That actually gives us a drop-down list of what's available. We make sure that we don't use the default station that has been used, and then we loop through the data. And remember, the data has been set up as a list of dictionaries. And then from there, it's very straightforward. So if we take a look at the application and go to our browser and look at the latest, notice that nothing happens. This is what is in the default display. Obviously, we could probably make some other adjustments to it, but that's what we have. So as soon as we select a station, it populates with data. So let's look at what happens when we receive a post request. So let's go back to the top of the function. Oops, come on. That's top of the function. There we go. So if we receive a post request, we still set up the default values. We check for a post request. We get the location from the form. And if we go to the latest, if we look at the form, so here's the label and here's the name. So based on that name, we get whatever is selected from the user, comes back here. We get that location. We make sure that it is not the default location. From there, we create a query string or a URL based on the location. And then we use the request to get the JSON data from this URL. Now, I've got this line of code in here, and sometimes it may happen that you may receive data that has some weird characters in it. You may need to experiment with encoding to make sure that you've got the right encoding to convert the data into the format that you need. So from here, once we've got the request data, we just simply receive the JSON data. Now we store that in the JSON data format. It contains only one key, this JSON data observations. And the observation contains three keys: notice, header, and data. And data's value is a list of dictionaries. So let's take a look at this. So if we copy the URL, and I'm just going to create a query or a URL from this. So I'm going to just get Brisbane Airport. Copy this, come over here. So just create the URL for this. Make sure everything is where it should be. And we will copy the oops, just double check. Yep, and let's just copy that. Go to our browser. Now we'll see the observation. So here we have notices, we have the header, and we have this information. So we have the name of what the data is about, and here's the data. So here's header, notice, and this actually has all the data that ends up getting displayed. Okay, so now we can see a basic structure that is being worked with here in our application. So coming back to our application. So now observations is the primary key, and underneath that we have header. We get the first value, name. So if we go back to the browser, so you can just see where the data is coming from. So here's observations, whoops, sorry, header, and then name. So that's where that information is coming from. So notice here this is 0, and we need to account for that in our code. So here's a 0, and that gives us the value for name. Again, we do the same thing. We get the message, and then from there we simply load the data into a data variable and then pass all that information to our template. So that's it. I have some other notes there, something to experiment with. And again, all that data gets displayed as what we saw in the example. So if we go back to, if we pick Brisbane Airport, here is the information for the Brisbane Airport. So going back to our application. Okay, so that finishes that example, and we'll close this. The Python SQLite Flask application produces a different set of files in comparison to the PHP application. The Python code file is used to access and process the data, and the template code files are used to present the data. The directory tree displayed shows the actual files needed for this application. The rest can be removed without negatively affecting the application. For this example, it's fine to use either the original MySQL script or use the SQLite script. If the MySQL script is used, the SQLite affinity converts the data types, and the application functioned without any problem. The affinity conversion of the data types was suitable for this solution. When using an existing MySQL script, it is suggested to check the results of affinity to ensure changes match requirements. Finally, the Python SQLite Flask application provides a basic solution requiring a minimum number of additional packages.